quick and dirty. Hey there, everybody. Welcome to my talk on cuttings and layerings, how to put Eric out of work, but also make him really proud. So who am I? I don't have a PhD in plants or botany or genetic engineering or any kind of cool things. I am just a nerd. I run a nursery down on the other end of town called Lally Luck Farm, so I am a nurseryman. And for tonight, I am an eccentric reproduction decider, which is what I'm hoping to empower you all to be this evening. So let's talk about plants. The big difference is that we have the option of letting things go to seed, and we're very familiar with seed saving from annual plants like tomatoes and squashes and cucumbers and peas and beans, the really, standard fare for getting started in seed collecting. Perennials are a little bit different, and there are similar challenges to sexually reproducing plants and getting all of the traits that we're looking to get. That's how we get variation. So sexual reproduction, you make a fluorescence and you attract your very, very particular pollinator, and then you hope that there is another individual with your genetic makeup in the vicinity that pollinator will then land on and pollinate, and hopefully that will make a fruit that produces a seed that is then viable in your environment. It's genetically messy, it's kind of dicey. If we're doing it, there is seeds that we have to clean and then potentially dry. Some plants don't like having their seeds dried and need to stay moist or at a certain hydration level to even germinate. And so there is storage things that need to happen. There are tons of things that you need to get into place, whether it's having a chill chest or a refrigerator to store all of your plant material and seeds. It's not a bad idea for some cuttings, depending on how much you're doing it. But then there's also unknown attributes, like you may have color variation, or there may be smaller berries, or a change in the scent profile, or the foliage or the flowers might change a little bit. Whereas with asexual reproduction of plants, we can very consistently control the attributes because they are going to be identical to our mother plant. This is cloning. This is basically photocopying our plants in a way that allows us to keep all of those positive attributes and make sure that we know exactly which plant we're dealing with and don't have as many surprises. So why would we bother with asexual reproduction when we could very easily collect tens of thousands of seeds from population where we are getting seed from? If we have all of these plants and they're making seeds, why not just grow from seed? Well, some species are particularly difficult to germinate. They have very stringent temperature requirements, plus moisture requirements, plus time, plus potentially paired species, plants that do better with colonies of another species nearby because they share certain nutrition profiles or they share certain fungal endophytes that partner with them. Sometimes those things are incredibly difficult to germinate. Orchids are a fantastic example of something that is next to impossible to germinate standard. Some plants hybridize very easily with other plants. Things in the buckthorn family are particularly known for this. Roses are particularly known for this. So if we wanted to get a population of a plant that hybridizes easily but is in its natural static form very useful for a population of insects or animals or stream bank remediation, things of that nature, it makes more sense to have a whole number of the same exact plant that we can establish a large population such that it can then self-seed true to species instead of having infertile or inviable seeds. Asexual reproduction is how we get cultivar species like really delicious Macintosh apples. I'm personally a fan of the Fuji's myself, but you know, Granny Smith's out there too. This is how we get things like autumn blaze, sedums, or specially colored Diablo 9-barks, or really interesting colored or variegated plants of a known and common species. You may have sentimental reasons to clone this plant. I have a couple of cuttings from my grandfather's jade plant, and I've never met my grandfather. He died a long time before I came onto this planet. But I have a piece of one of his passions growing in my home that I hope to pass down to my children and their children if they decide to have it. It is fun to make new plants. It is hands down the best addiction I have ever had in my life. And who doesn't love free plants? I do. I love free plants. I don't want to have to spend hundreds of dollars to get enough to fill my gardens. That's crazy. So we have some important words to know as we go through some of this cloning talk. We don't have to worry about the flowers. We don't have to worry about our modified leaves and stamens and carpels and pistils. What we are predominantly focused on is our buds. So our apical bud, the one at the very, very top of our stem, and then the axillary buds. We have some visual aids in case anyone is concerned that they're not going to be able to follow along. You can have it right up close and personal. And so the apical bud is the one that's at the very top of the stem, which is the upright portion that grows perpendicular to the profile of the ground. And so your axillary buds are any buds that are located on the sides. Some plants will have two at a given joint. Some plants will grow them alternately, so you'll have one and then another one on the opposite side lower, and then some are more of a rosette pattern where they will spiral down. If you think of really old apple trees and the way that some of their main branches will be kind of like a staircase going up the main trunk of those trees, that would be a different style, not alternate, but radial or a rosette. The nodes that we are going to be discussing are those points at which the secondary plant parts grow. So your leaves, your buds for flowers, additional branches, each of those come from a node where the stem is segmented in such a way as to allow further plant growth to occur. This one's really tricky. The internode is the part in between the nodes. So whatever your length is, that is the segment of shoot between each of those spots where you see buds or leaves or stems coming out. For leaf propagation, things like a lot of houseplants, spider plants, pothos, and things like that, as well as a ton of succulents, we're talking about leaf propagation. And so the petiole is the technical term for the bit of the leaf where the leaf blade, and so the big green section, that's your leaf blade, and the piece of plant that connects that blade of leaf to the main stem is called your petiole. And anytime you hear me say the word medium during this talk, I am not talking about the lady that you pay money to find out whether or not your plant is going to survive the cutting process. I am talking about the substrate, the soil, or other kind of mix, whether it's sand or peat or some kind of blended forest product that we are placing these cuttings into or that we are using to further propagate our plants. And so cuttings are sections of vegetative growth that we take to reproduce any given plant. If we are taking the flowers themselves, they do not have the requisite genetic information to make us the whole mother plant. They are a highly specialized form of those cells and do not give us the same kind of regrowth that we are aiming for. A lot of times those will just kind of rot and die, or you may get a burst of energy and they may put out a full flower display, but there's not enough oomph there behind them to actually generate seed if they were pollinated by any chance. And so, there we go. So for leaf cuttings, again, almost entirely used for things like succulents and houseplants. Sansevieria is another one. Some of them do require the petiole. None of the things pictured here require them, but a lot of the Sansevieria or the pothos will. Some leaf cuttings you can take into sections and place them just down on top of the substrate. Most of the time when we are taking non-petioled leaf cuttings, we want to just place them on top. This is following the genetic patterns and the evolutionary frameworks by which these plants reproduce themselves in colonies. And so a leaf would fall off, hit the ground, and then these plants that survived were best served by having systems in place to reproduce or root when they broke off from their mother plant. And so really we're leveraging these evolutionary schemes or habits, and to anthropomorphize just a little bit. Most of the species do not require the petiole attached when we are talking about succulents. For the most part, they will not necessarily even have a petiole unless they are the attached flower stalk of something like a hens and chicks or a mother of thousands. The main thing that I do on our nursery and homestead are stem cuttings. I'm very into fruit plants and bushes and perennial salad greens and things of that nature. So a lot of what I've practiced are stem cuttings, and there are a number of different ways that we can approach this topic. But a few key takeaways are that most of what's going on is a matter of timing, a matter of technique for taking the cuttings, and then making sure that we have a stable environment for these cuttings to root successfully and take hold. We can use things like auxin or IBA, indole butyric acid, to help push these plants to make new roots, but they aren't strictly necessary, and those compounds are known carcinogens, so just play it safe. When I say stem cuttings require particular timing, in a way that houseplants and a lot of succulents do not, because they are not cyclical with the seasons, they're not deciduous. For stem cuttings, there are a couple of different stages during the growing season and the non-growing season or dormant season that we can take advantage of. When you see a book or a resource tell you to take softwood cuttings, that is generally from the middle of spring to the earlier parts of summer. In New England, that would be May, maybe late April if you're southern New England, into the end of July. You'll see generally weakish stems. They will have some flex before they break, but they are not really very firm. It's usually just the top 6 to 12 inches of the plant till we hit that apical stem that we are looking for with those, as opposed to the semi-hardwood or semi-ripe cuttings, which are those later in the season but not totally lignified, not very, very woody structures in our plants. Those ones are primed to either break off and make new plants given interactions with wildlife or inclement weather, or they are set to become the scaffolding for the next season's growth if they successfully overwinter. These ones are going to have considerably more flex and not necessarily break as easily, and if they do break, they're going to kind of break in a more fibrous way than they would have if they were totally new shoots. And then our hardwood cuttings are the things that we take over winter or very late in the fall, after our leaves have dropped, after the color has kind of drained out of the stem and it's taken on that very dormant, woody look to it. That's when we're going to find that anything that's calling for hardwood cuttings is going to be most successful. Generally, you can do that during any portion of the winter in New England, which is kind of handy depending on how our seasons go, because not every winter is super cold or exactly the point where plants are dormant for December and part of January. When we are taking our cuttings, it's important to know whether we are aiming just for those apical stems or if the axillary buds are going to suffice for cuttings as well. My personal philosophy is if I'm going to harvest a branch for my cuttings, I am going to take as much as I can that is going to be potentially viable. And I'm going to increase the likelihood of my success by giving myself many, many, many chances. And so the stems that you're holding in your hand, it was 2 side branches off of one plant, but I took about 30 cuttings that I could stick in the ground, and though it is a little bit early for them to do well, they have a chance to root and succeed and grow fully next year. And so for our tip and medial cuttings, anything that is going to use our apical bud and any axillary buds, we can do 2 to 6 inches. Generally speaking, if the cutting itself is going to be smaller than a pencil's width, I try to give it a little bit more just so that there's a more full carbohydrate store that the plant can draw on to create those roots. We want to insert our cuttings deeply enough so that they do not wilt or fall over. Once they are uprooting themselves, we are losing that soil contact or that substrate or medium contact that allows them to feel the pressure and then send roots out appropriately. Those are generally inserted up and down in a similar orientation as we grew them in the first place, as opposed to cane cuttings, which certain plants do well with. You can do it with things like elder, you can do it with things like currant, although not in Maine. You can do it with things like sugarcane, although generally not in New England. Check your favorite books for propagation for some others that do well with cane cuttings. I really haven't done it too much, except with a handful of things like the elders, willows, and a couple of the ribes species that I have played with in other states. And then just a quick note that maintaining our humidity, because our cuttings do not have any way of drawing moisture into themselves through the roots anymore. They don't have it. So if we are being careful, we can keep them from becoming way too dried out, and that's going to give us a better chance of success in rooting. And we want to make sure that we are keeping them protected from UV exposure unless the particular instructions or directions from a trusted source for that cutting process says to do so. For example, sugarcane, you want to cut into sections and then allow to dry for 2 to 3 hours, and then you would place it down in this orientation parallel to the soil so that it can root properly. But it needs that stressor in order to trigger the physiological response. If you see a bad cutting, if you see one changing colors into things that look like rot, if you see them drying out and becoming very, very desiccated, pull them. Hoping for that one to succeed is not worth giving up on the rest of your cuttings. Rather than using IBA or root tone or those sorts of things, we can root a lot of our plants, both woody and herbaceous ones, in water before we place them into our pot mixes or into our gardens that have actual earth and soil. Be sure to change your water frequently. If you notice any kind of film or growth on it, change it more frequently. You can add small dilutions of apple cider vinegar to help kind of control some of those growths, but don't do more than like a 1 to 10, 1 to 15 ratio, because the acid may wreak havoc with the root structures that are trying to grow. These roots are different from soil-borne roots. They are more fragile. They do not respond to pressure the same way that soil-borne roots do. So when we are transplanting them, we have to take extra special care to keep from breaking them all off accidentally. So just be aware when you do move to transplant them out of a jar or out of a bucket that you are paying attention to how you are packing them into your soil or medium. And then if you find that you're having trouble, things like willows will produce more than enough rooting hormone for themselves to create a proper blend in the water that you are trying to root your other species. And so adding a couple of cuttings of willow to things like blueberries or other vacciniums, which are particularly challenging, or some viburnums, which can be a little challenging to root as cuttings. Adding willows will give you a slight edge and increase the likelihood of seeing those roots propping much faster and with less loss than you would see otherwise. I told you they didn't get better. So, some words of caution. Always, always, always disinfect your shears in between plants. It's very hard to see disease with the human eye without technological aids. And so, better safe than sorry. A 1 to 10 bleach and water solution, isopropyl alcohol. Bleach wipes work, but it's very wasteful. I have one of those little squirt bottles for hand sanitizer, and I just have it in my little plant belt, and I pump, and then I smear it on my snips, and I give them a couple of things, and then I shake it off, and then I move to the next plant. It keeps me from spreading diseases, milky spore, any kinds of molds or funguses between plants. Even though those diseases can spread, we don't need to give them a leg up as well. If you are using powders or root tone liquids or things of that nature, wear your goggles, wear your face mask, do it in a well-ventilated area, make sure to wear your gloves. Take the gloves off before touching your eyes or other mucous membranes. Play with these plants and these chemical agents in a way that protects your health, because they can do a number on you. Always check your manufacturer's safety data sheets and things of that nature as well. Always protect your cuttings from intense UV exposure and keep them moist unless otherwise directed. Don't take your cuttings and then leave them in the grass and then go have lunch with your friend the next state over and come back 4 hours later and think that you're going to be super successful. They do not like drying out that much. We need to make sure that the water that is in those cells is not being lost before it's being used. And then always mark your cuttings using an indelible marker. Wax is preferable. Some are wax suspended in alcohol. You can use things like a carpenter's crayon on pieces of wood that will last for much longer than a permanent ink marker will. Take it from me, there is nothing worse than having several hundred sticks in a couple of square feet and having lost their names and which plants they came from or what time I stuck them or how long they've been there, and having all of that information just lost in space and time. So cuttings are one thing, and by taking these cuttings, I was in trouble 3 words into this sentence, but we are cutting off this vegetative growth from its support network of the roots of its mother plant. And so we can make clonal cuttings of these plants without losing that support system throughout the growing season. We don't have to risk them running out of water or not having enough nutrient or not having the kind of photosynthetic capabilities that they need to really shine for us. And so we're also going to talk about layering our plants. And layering is the technique of making new plants root while they are still attached to their mother plant. I like these methods a lot because it means that I can save space when I am growing out new plants. I can generally just over-mulch certain species and have them produce roots and new plants that I can then, during fall cleanup, snip off, plant out somewhere else. And so we'll talk about a few methods of layering, which is, again, just a catch-all term for these handful of techniques. Oh gosh, I went 2 slides too quick. We'll go back one. And so with mound layering, we are creating mounds around our mother plants. A lot of fruit tree rootstocks are grown this way, but anything that produces a large number of branches, whether it's a heavily branching tree like quinces, or whether it is a multi-stemmed shrub like our elders or chokeberries or viburnums or blueberries, can benefit from this sort of technique. And so what we do is we allow it to grow one full season without us doing anything crazy to it. But once it's set out those roots, we give it a very hard heading cut, very, very low to the ground. Now, heading cut, just to review, is a cut that is made perpendicular to the main growth of our plant. So it's just cutting off its head, sometimes at soil level. And what this does is it makes the plant roots freak out, because now they don't have this apical bud that they're sending all of that information and chemical nutrition to. That whole pathway of growth is severed. And so what they're going to do is they're going to panic. They're going to go, oh no, well, how am I going to make fruit? How am I going to get photosynthesis? How am I going to get my sugars? And what they will do is the second year, they will produce many, many shoots. And so once we see them making those additional shoots, generally you want to cut off at just where one of those nodes are, and that will promote this extra branching. Once we see those extra branches coming from those nodes, we start to pile up inert, low nutrition mulches or other substrates or mediums around the base of this plant. And throughout the course of the season, as these side branches grow, we're just adding to it periodically, and the plant's own response is going to be that it's going to push out new roots into this newly available material. This is an evolutionary adaptation to being understory plants. A lot of those super tall, not very often branching trees will not have this particular habit, but a lot of our understory trees, shrubs, and herbaceous plants will. And so we can use this particular adaptation of theirs to bulk out our gardens. Once the growing season is over, we can go in again and take a small cut at the base where each of these now rooted stems attaches to the original stem of the plant, and we've made additional copies of everything. Trench layering is a little bit different. I have not been very successful with this myself, but it does not stop me from trying because it seems pretty cool. And so for this, I have seen that a number of citrus plants are grown in cloned using trench layering, where our mother plant is planted at an angle, sometimes 45 to 60 degrees. There is a name for that angle of planting that I don't recall anymore, but Anne Ruth's Grow a Little Fruit Tree has, Anne Ralph's Grow a Little Fruit Tree has a number of these examples. But so we would plant our plant at an angle so that it is taking up less vertical space, because our second step is to bend it after the first season of growth so that it is laying flat along the interior of our trench. And what we do is we then cover those top branches, the main sections of side growth. We cover them with our soil medium, and those will then push additional upward vegetative growth from those side shoots. Again, we let it grow for a season, and then we clear the trench out around those cuttings that we are going to take. And each of the side shoots coming off of those side branches will have roots to them. lemon trees, limes, and certain types of orange, I believe, are cloned this way. And I know that there are certain types of apples that are also done this way. We have tip layering, which anyone who has ever had forsythia or has seen raspberries going or any of these types of drooping plants, tip layering is how they naturally propagate themselves, sort of walking themselves out into distances. And so any canes or branches can be bent away from the mother plant, either into a pot if we're looking to transplant them very far away, or if we're just looking to grow the footprint of, say, a berry patch, we can do it just right down to the ground. It doesn't have to use staples as pictured. I've used logs, I've used rocks, I've used other potted plants that I was thinking about sticking in this garden and just figured I could use the extra weight while I make my choice. Anything that just holds that branch or cane down to the soil will give it an opportunity to root. One of the things that I have found and that other people have written about as far as improving the chances of it rooting is to make a small wound around the nodes of the plant where the soil is going to be touching. And this just kind of spurs that plant to create new cells to kind of partition that damage that has been caused. But the contact with the ground is what promotes the root growth. And then we have a couple of pictures of some of our black raspberry cuttings that I've taken. And you can see them in a range of progress from tip layering. And so the first handful, we can see that the differentiation, the color is totally different between, say, the one that's on the far right here, which is a slightly more matured one. You can see there's a significant amount of lightening. The chlorophyll has very much left because these have been buried in soil for a short period of time. And we can see that the foliage is still growing down towards these growth tips that have been buried. The furthest left has almost no root structure being created, but then just even an additional week in the soil, you can see these very beginning root protrusions, which with an additional week will become more definite and may put on a significant amount of length that will allow them to support themselves once we're transplanting them. The leftmost one on this image was the second to rightmost one on the previous image, but we can see that after that point, the roots really start going, and by the time we get to about 6 weeks to 8 weeks in the soil, we can see that some of the foliage is even growing away from this growth tip now because the roots are sending that signal to grow away from them in the plant. And so it doesn't always take a very long time, but each of these is a viable cutting that we took from our black raspberries that are completely self-sufficient at this point because we gave them just that little bit of time to get things started ahead of us. And so